thorough. All right. Let's see what I got for you. So find dy dx given square root of xy equals x minus 4y. So how's this work? So if you're trying to find dy dx and you have an equation where y is not solved for, you want to do implicit differentiation, which means take the derivative of both sides, okay, with respect to x. So what we're going to do, I would probably rewrite this as the 1/2 power. Right? This is xy to the 1/2 equals x minus 4y. And then you derive with respect to x. Now you have to be a little careful. You have to be a little careful here. How does this left side work? How do you do the derivative of xy to the 1/2? Chain rule. It's actually technically a couple of chain rules. Well, there's two ways you can do it. You can either do a chain rule, or you can split it up into x to the 1/2, y to the 1/2. Right, if you do it like that, then it's just product. So we can do it like that. And I can show you the other way. So because this is multiplication, you can split this exponent, you can put it to each of the factors here. If this weren't multiplication, if it were like addition, you wouldn't be able to do that. But it is, so we did, and now, how does this derivative work? So you do the derivative of the first times the second, plus the first times the derivative of the second, right? It's a product rule. So
1/2.
yeah, so we'll get 1/2 x to the negative 1/2 times y to the 1/2, derivative of the first times the second, plus the first x to the 1/2 times the derivative of the second. 1/2 y to the negative 1/2 times dy dx, right? The derivative of the inside function, the derivative of y, dy dx. So that's the left side. On the right side, the derivative of x is 1, so that's pretty easy. The derivative of negative 4y is what? 4. Minus 4 dy dx. Okay. So now we've done all derivatives, we just have to isolate dy dx. How do we do that?
Subtract the 1/2 x minus y.
So these two terms have dy dx in them, so I need it on the same side. So I guess there's a couple ways to do it, but let's go ahead and move. Let's subtract this whole, actually we'll just subtract this whole term. X to the 1/2 times 1/2 y to the negative 1/2 dy dx. So I'm going to subtract this whole thing over here. Minus x to the 1/2, 1/2 y to the negative 1/2 dx. Subtract that, and then this 1 has to move over to the other side, so I'll subtract him like this. So these will be gone. These will be gone. So what we're left with looks like 1/2 x to the negative 1/2 times y to the 1/2 minus 1. Equals negative 4 minus negative 4 dy dx minus x to the 1/2. I'm going to put this out in front. Minus 1/2 x x to the 1/2 y to the negative 1/2 dy dx. So just subtracting, like, subtracting terms over the other side, there's ugly terms. That's okay. And then what's the trick? How do I get a single dy dx out of this? Factor. So we have -4 minus 1/2 x to the 1/2 y to the negative 1/2 equals this. You divide by this monstrosity. Divide by this whole factor here. Ends up going away. And you got to do it to the other side as well. So altogether, dy dx, the derivative of y with respect to x, is 1/2 x to the negative 1/2 y to the 1/2 minus 1 over this. If you wanted to simplify this, you'd have to make these negative exponents. You have to bring them down to the bottom, and then you'd have to multiply. I'll show you, and then you forget it. It won't matter, so don't bother. Questions about the calculus, though? All right, you guys see how these derivatives work? Did I lose you anywhere? No? Okay. Alrighty. How would I do the derivative if I didn't split it up like this? Remember back here I said you don't have to split it up. What if I wanted to do this derivative without splitting it up because I didn't remember that rule? The 1/2 has to come down first. Keep the inside exactly the same. And then what's the exponent here? Negative 1/2, right? So we're doing the chain rule where you do the derivative of the outside first, then times the derivative of the inside. The derivative of the outside is 1/2 xy to the negative 1/2. Then what do I multiply by?
Product rule.
Yeah, the derivative of the inside is a product rule now. So you have to go derivative of the first, which is 1, times the second, plus the first times the derivative of the second. So, I think we probably saved ourselves a little bit of algebra by doing it this way. Because to isolate dy dx, now we'd have to distribute. Right? If we're trying to isolate this, we have to get rid of these parentheses. We think this is the short one. Okay? So I didn't show you last time, I'm going to show you right now, how to take the second derivative implicitly. Derivative of the derivative. Just want to do an example about that. This is still related to rates. I mean, not related rates, implicit differentiation. So I want to find d squared y over dx squared if x plus cos y equals 2. What? Do you remember this? Yeah. What does this represent?
The second
derivative.
Yeah.
Right, so our notations for derivatives, if you do prime, the function, maybe the function called y, then the first derivative is 1 prime, second derivative is 2 primes, 3 primes, and then you start putting a number in parentheses. Right, So this is derivatives if you're using prime notation. If you're using the d notation, then the first derivative is dy dx. But the second derivative is d squared y dx squared. That's the notation. And then this would be d cubed y dy cubed. But this just means second derivative, which means we're going to have to first find dy dx and then take the derivative of that. So because y is not solved for, I'm going to do implicit differentiation. So x plus cos y equals 2. Derive both sides with respect to x. Yeah, so on this side, derivative of x with respect to x is 1. Derivative of cosine y is what? Negative sine y dy dx. So that's equal to 0, right? Derivative of a constant. Cool. So now we solve for dy dx to get the first derivative, which means subtract 1. Negative sine y dy dx equals negative 1, and then divide by negative sine. So dy dx is equal to 1 over sine y. Or, what's this equal to? Cosecant, yeah. So here's our first derivative. To get the second derivative, I have to take the derivative of both sides again with respect to x. So if I take this answer and I do d dx, derivative with respect to x, on both sides, the derivative of the derivative means the second derivative. So that's my notation. And then over here, I have to do implicit differentiation on cosecant of y. So what's the derivative of cosecant? Negative cosecant cotangent. Right, remember the cofunctions always pick up a negative, and then cosecant is going to be itself again, but it also picks up a cotangent. And then times dy dx, right? Because there's an inside function of y, so you multiply by the derivative of the inside. So this is the second derivative, but it's kind of ugly. It's in its ugliest form, right? Because I really don't want an extra dy dx in there if I can help it. And it turns out I can help it because back here, I have what dy dx equals. Remember, we ended up with dy dx equals cosecant y. That's what we started with. Mm-hmm. So I can go in here and plug in cosecant y. Mm-hmm. So the formula for the second derivative in terms of just x and y, just y, it'll be negative cosecant y cotangent y times cosecant y again, or negative cosecant squared y. So you can use implicit differentiation to keep finding higher and higher order derivatives, second, third, fourth, fifth. But after you find the second derivative, go back in and replace your dy dx with the first derivative just to make it look pretty. If I wanted to find the third derivative, now I do d dx on both sides again. And then I would replace dy dx, and if I got one, d squared y. I won't get one. I'd replace dy dx. That's really the only new thing.
The y prime to the third, was that just on accident, the dy cube?
On the bottom? Yeah, dy cubed. I mean, it's just,
This cube is
no, that was a typo. This should be x. I hit the wrong keys. I'm going too fast. So what do you think? You guys need another one of these, or are you good with these? Oh, you're just going to stonewall me. You okay finding the second derivative, you think?
Mm-hmm. It was a harder one.
A harder one?
It's not.
This one wasn't hard enough?
I just want to see how hard it gets.
You just want to see how hard it gets. Just to be ready, huh? All right. I don't have a super difficult example, but I do have a slightly more difficult example. Find second derivative if x, y squared equals this is harder only because you're going to have product and quotient rules to deal with. So for example, to start this, to get to the second derivative, I'm going to have to first do the first derivative. So I do d dx of the first left side, xy squared, equals the derivative of 1. What happens here? How do I do the derivative of x times y squared? Product rule, right? So derivative of the first times the second plus the first times the derivative of the second. So let's break this down here. Derivative of the first, 1, times the second, staying exactly the same, plus the first times the derivative of the second. What's the derivative of the second? 2y.
equals 0.
And then you have to do the derivative of the other side. So. Is that good? Now I have to solve for dy dx, so I'm going to subtract the y squared. So this is going to become, let me change the order here, 2xy dy dx equals negative y squared. Divide by 2xy. So dy dx is equal to what? Negative y over 2x. Right, because a y on top and a y on bottom reduced. So then you got to do second derivative, right? Derivative again. So the derivative of dy dx equals the derivative of negative y over 2x. So the left side is just the second derivative, the derivative of the derivative, second derivative. Okay, so now on the right I'm going to have to do a quotient rule. You want me to write it out, or can we do it in our heads?
Do it in our head.
All right, let's try to do it in our heads and see how much you cry. All right, so if you're doing a quotient rule, you do the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. So the derivative of the top, negative 1 times the bottom, minus the derivative of the bottom times the top, negative y times 2, over 2x quantity squared like this.
Is there dy dx?
Yeah, what did I forget right here?
The first part.
Right here.
Negative dy dx.
Yeah, this is garbage. When we do the derivative of the top, when you do the derivative of y, you always have to get a dy dx.
So it's negative dy dx.
Which I can't fit in. So negative dy dx times 2x. The derivative of the top is dy dx. The second one doesn't need it because we didn't do the derivative, right? We just left this one the same. It should be good. Let me clean it up a little bit. I got it. Yeah. So d squared y dx squared, the second derivative, equals negative 2x dy dx plus 2y over 4x squared. And then what should we do to make this look a little prettier?
Plug it in.
Yeah, plug in what we know. We know first derivative. Yeah, that's exactly the sound that the first derivative makes when you move it down. So d squared y dx squared equals negative 2x times negative y over 2x. Like that. Plus 2y over 4x. So what do you think? This one I would definitely simplify. What happens here? 2x's fight to the death. This minus and this minus become plus. So we have y, not purple, y is black. Y plus 2y over 4x squared. 3y over 4x squared. I think that's it. That's it. Can't forget that UIDX. You saw me try and pull that nonsense. So don't be like me. Is there a shortcut? Yep. Yep. I'm not going to tell you. Sorry. You don't deserve the shortcut.
Okay.
Shortcut to do what? Implicit differentiation? I don't know. I don't know if there's a shortcut. Sometimes what you can do, right, this equation, it's simple enough you can solve for y here. And then do the second derivative after you solve for y. If you divide by x and square root both sides. In the last example, you couldn't solve for y because it was, if you remember, it was x plus cos y equals whatever, 2 or something. If you try to solve for y, you have to subtract x and then take cos inverse, and we don't know the derivative of cos inverse. So solving for y would not help you. But here it would, maybe, because you get 1 over square root of 1 over x, and then you can do the derivative.